Number 1 wants to know which expression is equivalent to this given fraction. Now, a really easy way to do this is to use your calculator and cheat. You can plug this original expression into your calculator, okay, this fraction here, and then you can plug in the answer choices one by one and see which one matches up. Okay, but I'm going to do it out the right way. So here we're going to do long division. So with long division, we want to take the numerator and divide it by the denominator. So the numerator goes under the division bar, and the denominator goes on the outside. All right, so you want to look and you want to say, what can I multiply x by to give me 2x to the fourth? So we can multiply that by 2x cubed. And then we're going to take this 2x cubed and distribute it to the x plus 6. So 2x cubed times x is 2x to the fourth. And 2x cubed times 6 would be 12x cubed. Okay, so now we have to change our signs, right, because we want to subtract, so we're going to change the sign and circle it, change the sign and circle it. Okay, we always use the circled sign. And then the first two terms cancel off, and positive 8x cubed minus 12x cubed would be negative 4x cubed. Okay, now we want to bring down the next term, minus 25x squared, because if we have two terms out here, we want to have two terms down here. Okay, so then you say, well, what do I multiply x by to give me negative 4x cubed? So that would be negative 4x squared. Okay, so now let's take the negative 4x squared and distribute it to the x plus x. So negative 4x squared times x is negative 4x cubed, and negative 4x squared times 6 is negative 24x squared. Okay, so then we're going to change our sign and circle it, change our sign and circle it. All right, so your first two terms should always cancel off. If not, it means, you made a mistake somewhere. And then when we combine the negative 25x squared and the positive 24x squared, that gives us negative x squared. And we're going to bring down our next term and just keep going with this process. All right, so what do I multiply x by to give me negative x squared? Well, negative x. So then negative x times x is negative x squared, and negative x times 6 is negative 6x. Okay, now this time when we change our signs and circle, you'll notice here that both terms cancel off. So what we're bringing down here is our remainder. So we're just going to write, how we write that remainder is we write at the end of this expression here, we're just going to add on the remainder and put that over what we were dividing by, because we're left with 14 out of the x plus 6 we were dividing by. So that would be choice 3. Okay, so number 2 gives us what cosine of theta is equal to, and it tells us that theta is an angle in quadrant 4. And it gives us this formula. I mean, it's multiple choice. We don't have to use this formula if we don't want to find tan of theta. I actually think it's easier not to use this formula. So I'm going to go about it. I mean, if you look on the written answer key that I give you, you'll see I did it using, this says method 2. I did it using this formula as well. But I'm just going to draw a bow tie triangle. So if we know that we have an angle that terminates in quadrant 4, all right, let's draw, I'll do it over here. Let's draw a fourth quadrant angle. So we have, here's the initial side, and what's going to happen is it's going to open up and open up and open up, and it's going to terminate over here somewhere in quadrant 4. So there's our fourth quadrant angle. Now what we want to do is we want to make that we want to connect that terminating side to the x-axis. So I'm going to take this and connect it to the x-axis, and we know this angle in here is called our reference angle. Okay, now let's just look at this right triangle here. And make that into a right triangle, so put a little right angle there. Now, if they tell us that cosine is equal to 7 over 25, think about SOHCAHTOA. Let me just write this out. SOHCAHTOA. Okay, we know that cosine is equal to adjacent over hypotenuse. So what that means is that this 7 here represents our adjacent side, and this 25 represents the hypotenuse. Okay, before I go any further, we know that we're going to put the theta where our reference angle goes, right here. Okay, it's always the angle. That's supposed to be theta, so it's hard to fit. But that's always the angle. That angle always goes like, right next to the origin, the angle that's closest to the origin. So if we're looking at this angle, right, we know the side across from it would be the opposite. We know the side next to it. Well, there's two sides that are next to it. The one that's the longest side across from the right angle is the hypotenuse. So the other side that's next to it is called our adjacent. So when we said that cosine is equal to adjacent over hypotenuse, let's put the 7 where the adjacent is. And let's put the 25 where the hypotenuse is. So now if we want to find this opposite side, it's really easy. We have a right triangle, so we can do a squared plus b squared equals c squared. Okay, the longest side has to be c, and other than that, you can use either one of these two legs as a or b. It doesn't matter. All right, so I'm going to do a squared plus 7 squared equals 25 squared. Okay, so when we square 7, we get 49, and when we square 25, we get 625. So then if you subtract 49 from both sides, it leaves us with a squared equals 576. And then the square root of that technically is positive and negative 24, but we're just going to take the positive because you can't have a negative side of a right triangle. Okay, let me just make these stand out more. So the adjacent side is 7, the opposite side is 24, and the hypotenuse is 25. And what they want us to do is they want us to find right here tan of theta. So we know that tan of theta is equal to, just look at your formula over here, opposite over adjacent. And also you have to think about whether this is positive or negative. So if we're in the fourth quadrant, right, all students take calculus, C, cosine, and its reciprocal trig function of secant are the only trig functions that are positive in the fourth quadrant. So tan is negative. So it's going to be negative. All right, so then let me bring down the negative sign. And opposite is 24, and adjacent is 7. So we're left with negative 24 over 7, which is choice 2. Okay, so when you read number 3, a fast food restaurant analyzes data to better serve its customers. After its analysis, it discovers that the events D, that a customer uses the drive-thru, and F, that a customer orders French fries, are independent. Okay, so they're independent. Now, what I put at the bottom of the screen here was I put the 2 rules that we have to know for independence. The first rule, this one we've used a lot this year. The probability of F and D equals the probability of F times the probability of D. So if the 2 events are independent, they'll fit nicely into this formula. Okay, the second rule is the probability of F given D is equal to the probability of F. And if you think about this one, I mean, if the 2 events are independent, then the outcome of D will have no effect whatsoever on the outcome of F. So that's why the probability of F given D, doesn't matter if this is given. It's not going to affect it. So it's just going to be equal to the probability of F. Okay, so anyway, if we look at this, it looks like this one is using our second rule here. Given this information, so since they're independent, the probability, let me just write this down here, the probability of F given D is going to be equal to the probability of F. Now, if we look up here, it tells us the probability of F is 0.8. So since the probability of F is 0.8, we can just replace this right here with a 0.8. Okay, so that's going to be our answer right there. Choice 4. Okay, so number 4 wants to know what's true about the graph of f of x. So what I did was I just went to y equals in my calculator and I graphed this, and this is what it looks like. Now, what you could see is it's, as the x values are getting bigger, the graph is going down. It's decreasing. It's kind of hard to see what's going on over here. I mean, if you want, actually, you could just go in your calculator to zoom in, right? Zoom, hit choice 2, and hit enter, and let's see what happens. Okay, so I'm zooming in here. I mean, you can still see it's decreasing, right? It's going through the point right here, 0, 1. And what's happening is, it's kind of hard to tell from your calculator, because your calculator, it only has so many pixels. So there's so many, once it hits a certain level, it can't show that it's getting closer and closer and closer to the x-axis, because this right here is that pixel above the x-axis. But with an exponential function, this would be exponential decay, your graph is going to get closer and closer and closer to the x-axis without actually ever touching it. So let's just go through the answer choices. Okay, choice 1, the graph is always increasing. Nope, we can see right away it's not. Choice 2, the graph is always decreasing. That's exactly what's happening. It's going to get closer and closer to the x-axis without actually ever reaching it. And just the other choices, the graph grows through the point 1, 0. No, it doesn't. It doesn't ever touch the x-axis. It does go through the point 0, 1, but not 1, 0. And then choice 4, the graph has an asymptote at x equals 0. So an asymptote is a line that a graph approaches but never reaches. Now x equals 0 goes through the x-axis at 0. So the graph does not have an asymptote at x equals 0. The graph has an asymptote at y equals 0. See this line right here? What's happening is the graph is going to come closer and closer and closer to that line, but it's never actually going to reach it. So that's called our asymptote. So if this said the graph has an asymptote at y equals 0, that would be true, but this one is not. Number 5 wants to know what would happen to the graph of this function right here if we translated it 1 unit to the right and 1 unit down. Okay, well, let's see what happens to our equation first. So we know that if we were to move horizontally to the right 1 unit, what we do is within the parentheses with the x, we're going to subtract 1, right? This is a horizontal shift of 1 unit to the right. Then if we want to move 1 unit down, we're going to subtract 1 on the outside of the parentheses. Okay, we're going to subtract 1 from the end of the function. So I would just go to y equals in my calculator and just plug this in. And remember, if you want to insert a base, once you go to y equals, you have to go to math and then scroll. It's faster to scroll up until you get to log base, and that'll allow you to type in a base other than 10 onto your log right there. Okay, so they want to know what are the coordinates of the x-intercept. Now, it looks like it's at 3, 0, but if you want to just double check, you can go to your table of values, and you'll see here that it does go through the point 3, 0. So this right here would be our x-intercept, so choice 4 is our answer. Okay, number 6, the easiest way to do this is just to use your calculator. So they want to know which equation has 1 minus I as a solution. So I would just store x as 1 minus I in your calculator. So all you're doing is just typing 1 minus I is second decimal, and then you're hitting the store button, which is right above on x, and hit enter. So whenever you hit x in your calculator, it'll represent 1 minus I. Now what you're going to do is you're going to plug in the left-hand side of these equations, one by one, and see which one is equal to 0. So when you plug choice 4 into your calculator, it'll give you 0. So there you go. Choice 4 is the answer. If you wanted to do it by hand, what you could do is you could just go through and plug each of the answer choices into the quadratic formula one by one and see which one gives you 1 minus I as a solution. Okay, so here's our quadratic formula. I'm just going to jump right down to plugging choice 4 into it. So we would have x equals negative 2 would be positive 2, plus and minus the square root of negative 2 in parentheses squared minus 4 times 1 times 2 over 2 times 1. All right, so we have x equals 2 plus and minus the square root of 4, positive 4, minus 8 would be negative 4 over 2. Okay, so then this is going to be equal to, actually let me work this way, 2 plus and minus. So since the square root of 4 is 2, and the square root of negative 1 is I, the square root of negative 4 would be 2I. That's over 2. And then since each of these terms are divisible by 2, let's divide them by 2. So they all become 1. So this would be 1 plus and minus 1I over 1. Or technically just 1 plus and minus I. So 1 minus I would be a solution. Number 7, the population of two small towns at the beginning of 2018 and their annual population growth rates are shown in the table below. All right, assuming the trend continues, approximately how many years after the beginning of 2018 will it take for the populations to be equal? Okay, so I mean, if this is their annual growth rate, we can just use the basic exponential growth formula. All right, so let's start with Jonesville. So Jonesville has in 2018 a population of 1,240. So we can replace the P, I guess the initial, the P, with 1,240. And then inside the parentheses, it's 1 plus the rate. So this would be 1 plus 0.06, which is just 1.06. And I'm just going to raise that to the t power, the x power, whatever you want to do. Okay, now for Williamstown, they initially started with 890 in 2018, and since they're growing at 11%, that would be 1 plus 0.11, so that's 1.11, and we'll raise that to the t power. Now we want to know when will they be equal. All right, so you could solve this, I guess, algebraically if you wanted to, but I think, it's multiple choice. The easiest way is I would just go to y1 in your calculator and plug in this, and y2 in your calculator and plug in this, and we're looking for the t value of the point of intersection, so the x value of the point of intersection. So, I mean, if you hit graph, you're not going to see the graphs. You could tell right away. I mean, these are going to start really high. Look at the initial population, and then it's going to grow from there. So an easy way to get the graph in the picture, I just hit zoom, and I scrolled down to choice 0, which is fit. I went to zoom fit, and this is what they fit in the calculator for us. Now, if we want to find the point of intersection, you're going to go to second trace. See on top of trace it says calc. We can calculate anything we really want about our graph. So if you go to second trace and then choose choice 5, which is intersect, just hit enter, 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 and it'll give you this point right here of intersection. All right, so it's approximately 7.2 and 1,885.9. Okay, now, if we look at what each of these represents, the t value or the x value is going to represent years, and the y value is going to represent the population. So really what we're looking for here is our t value. So that would round to 7 years. Okay, now let's be honest. This is multiple choice. So, I mean, you did have to know how to create this equation right here. But once you create that equation, you could just plug the answer choices in one by one and see which gets both sides of the equation to be as close as possible. All right, so number 8 wants to know which statement or statements about statistical studies is true. So choice 1, a survey of all English classes in a high school would be a good sample to determine the number of hours students throughout the school spend studying. All right, well, I mean, that would be, I think that's an appropriate statement because I'm going to say, yes, that one's good, because we're looking at English classes, which is a class that everyone takes. It's not like you're just looking at band, or you're just looking at an art class, or you're just looking at a particular math class, okay? So, yeah, you're looking at a, good variety of everyone. All right, choice 2. A survey of all 9th graders in a high school would be a good sample to determine the number of student parking spaces needed at that high school. Well, 9th graders shouldn't be parking because they don't drive, so that is not going to be our answer, so we're ruling out that one. All right, 3. A survey of all students in one lunch period in high school would be a good sample to determine the number of hours adults spend on social media websites. Well, I don't know why we would survey students to ask about adults, so I'm going to say no on that one either. And then choice 4, a survey of all calculus students in high school would be a good sample to determine the number of students throughout the school who don't like math. All right, well, calculus, you're only kind of like looking at one particular group of students here, and usually calculus, I mean, that's one of your higher math classes, so I can't say, it's foolproof here, but usually if you take calculus, you're better at math, which in turn may make you like it. So I'm going to say that's probably not a good survey there. So the only one that looked good was choice 1, so 1 only. Number 9, the function n of t models the number of grams in a sample of cesium-137 that remains after 2 years. On which interval is the sample's average rate of decay the fastest? Okay, so average rate of decay, they're just looking for the average rate of change. So we know this here is our average rate of change formula. So we're just going to go through these intervals one at a time and plug them into the average rate of change formula and see what we get. Okay, so these values, this represents x1 and x2. So let me start off with choice 1 here. So x2 is 10 and x1 is 1. So that's going to be our denominator. Now, to find y2 and y1, we need to take these x values and substitute them into the function, right? Because n of t is another way of saying y equals. So we want to figure out what y is equal to when x is 10. Let's just replace the x, or in this case the t, with a 10. So since I started with x2, let's start up here with y2. So I'm going to just take this 10 and substitute it in. So it'll be 100 e to the negative 0.023 times 10. Okay, so now I want to subtract from that y1. So I'm going to take x1, which is 1, and substitute it in for t. So I'll have 100 e to the negative 0.023 times 1. Okay, so now I'm just going to plug this into my calculator. And when I do, you could see I get approximately negative 2.03. Okay, now I'm going to do this for each and every one, and it's really easy to change in the calculator because look, like when I get to choice 2, I'm just going to use x2 is 20 and x1 is 10. So this denominator, I'm just going to scroll back and change this to a 20 and this to a 10. And then I'll change this 10 to a 20, and you can't see it, but there's a 1 over here. I'll just change that to a 10 and then just hit enter again. So when you do, that's what I did here, okay? I just changed my numbers. In the calculator, I literally just scrolled back and changed them, and this is what I would get for choice 2. So you're going to go through and you're going to do that for each of the answer choices. Okay, so this is what I wind up getting for choice 3, and this is what I wind up getting for choice 4. So you could see choice 1 was changing at the fastest rate. Let me just circle that. Number 10 wants us to solve for the value of x. Now, I personally think the easiest way to do this one is to plug the left-hand side of the equation into y1 in your calculator. Okay, so take this 2x and plug it into y1. Take the right-hand side of the equation and plug it into y2 in your calculator. And then just go to second trace intersect and determine the x value, since there's only x's in this equation, of the point of intersection. Okay, so you could see that it occurs right here at 2.5. Well, this 5 is going to round that up to a 6, so at 2.6, so choice 2. Now, some of you may have said, you know what, this is multiple choice. Let me just take the answer choices and plug them in and see what checks. And you can do that. The only thing is that when you plug in these answer choices, right, like if you take in 2.6 and plug it in for x here and x here, it's not going to check exactly because this is a rounded value. Really what you're going to have to do is when you plug this into the left-hand side of the equation and the right-hand side of the equation, you're going to have to see if the difference between those values is smaller than the difference between the values when you plug in the other answer choices. Here, let me show you what I mean. I don't really recommend doing it this way, but I'll show you what I mean. Okay, so what I did here was, on this side, I took the first answer choice of 2.5, and I just substituted it into the left-hand side of the equation, so 2 to the 2.5, and then I also substituted it into the right-hand side of the equation. And I saw what these two values were. Now, they're not equal. Even if this was the answer, they're not going to be equal because 2.5 is a rounded value. So what I did was I subtracted these two values to see how off they were. So they were off by about 0.343. Okay, then I took the next answer choice and plugged it into the left-hand side of the equation and plugged it into the right-hand side of the equation. And these were the two values I got. Now I wanted to see if the difference in these two values was more than or less than what I got over here. So when I subtracted them, I found the difference to be about 0.26. So, or 0.263, however you want to say this. This difference is smaller than this difference. So what that means is when you substitute this answer in, you are going to get two sides of the equation that, are, I don't want to say more equal to each other, but that are closer to each other. So this would be the rounded value. Again, I don't recommend doing it this way. I would just plug this into y1, plug this into y2, and find the point of intersection and just round. I guess since all the answer choices are rounded to the nearest tenth, just round to the nearest tenth. Okay, so number 11 gives us two equations, and they want us to determine one solution to the system. All right, I would do this graphically. I think the easiest way would just be to take the first equation they give you and plug it into y1 in your calculator. And then I would take the second equation they give you. You have to solve for y, but that's pretty easy to do. Just subtract 3 from both sides of the equation. So that leaves you with y equals x minus 3. So then I would just go to y2 in your calculator and plug in x minus 3, and then just find the point of intersection. Okay, now what's a little bit tricky about this is when you graph it, it's kind of hard to see. If we're in our negative 10 to positive 10 window, it's kind of hard to see if there's only one point of intersection here or 2 points. So you know what? I'm going to hit zoom and then choice 2 in, and I'm going to move the cursor kind of by where I want to zoom in and hit enter. And let's see what we see. So if you notice, there actually are 2 points of intersection. There's one right here, and then there's also one right here. Okay, so let's find them both and see which one is up here. All right, so I went to second trace intersect, and I found that one point of intersection was at -2, -5, which we don't see up here, and then -1, -4, which is choice 2. You could have also done this algebraically if you want, but being that it's multiple choice, I felt like this was a really easy way to do it. So number 12, the graph below represents national and New York State average gas prices. Okay, so it says that New York State's gas prices are represented by G of X. So if we look, New York State is the one with the just dots. So this is being represented by G of X. So they want to know which one represents the national average gas prices. Well, if you look on this graph, you can see that the national gas prices are shifted down from G of X. So we're looking for which one of these expressions shows that we're shifting down. Okay, well, choice 4 right here does. If you subtract a value from the end of a function, it's going to shift it down. Choice 2 would have shifted it up. And then if you add or subtract a value within the parentheses, that's going to shift it horizontally. If it's an addition sign, it shifts it to the left. And if it's a subtraction sign, it shifts it to the right. All right, number 13 wants us to find the inverse, which they're calling G of X, of f of x. So we know inverse means to switch the x and y values. So technically, this f of x represents a y value. So we're going to switch this to an x, and we're going to switch this x to a y. So that'll leave us with, I guess I'll fit it over here, x equals 1/2 y plus 8. Okay, so now what we have to do is we have to solve for y. So we can subtract 8 from both sides of the equation, leaving us with x minus 8 equals 1/2 y. And then rather than dividing by 1/2, rather than dividing by a fraction, I like to just multiply both sides of the equation by the reciprocal, which is 2 over 1. 2 over 1 is the same thing as 2, so I'm just going to put a 2 on this side. All right, so what happens is the 1 on top cancels with the 1 on bottom, the 2 on top cancels with the 2 on bottom, leaving us with just y. And when I distribute the 2, I get 2x minus 16. Now all you have to do is go back and change this to G of x, what's being, what represents the inverse function. So I'm going to rewrite this as, let me get my pen, G of x equals 2x minus 16. So choice 2. All right, so number 14 gives us the equation of a parabola, and they also give us the directrix, and they want us to find the focus. Now, we could tell that this parabola opens up because it starts with y equals, and it's positive. So this is the format of a parabola that opens up, where the vertex, hk, can be found here and here. Okay, so if we look at this equation, we could see that in place of h, we have a 2, and in place of k, we have a 2. So that means our vertex is going to be at 2, 2. Okay, and then since in the denominator of this fraction it says 4p, we want to think about 4 times what would give us 12? Well, 4 times 3. So that means our p is equal to 3. All right, so let's graph this out and let's see what we're left with. So we have a vertex at 2, 2. So let me first just plot that. Okay, so at 2, 2, we have the vertex of our parabola. And we know it's going to open up, so I'm just going to go like this for now. Okay, so then if p is equal to 3, that means that the focus is going to be 3 units up from this. So let's go 3 units up, and we can plot our focus. So the coordinates of that would be 2, 5. All right, so actually that's what they were looking for, so that's our answer. But if we do want to just check further, we know that the directrix would be 3, would be the line that if you were to go 3 units down, so 1, 2, 3, which would be right here at y equals -1, and that is what they gave us. So it looks like it all checks out. Number 15 is another parabola question, because we know a parabola is a set of points that's equidistant, which means an equal distance from a line and a point, and that's what they're giving us. They're giving us a line, they're giving us a point, and they want us to find the set of points that's equidistant. So, first thing I'm going to do is, if this is representing the directrix, and then this would be representing the focus. So the vertex is halfway in between them. So if there's 1, 2, 3, 4 units in between them, the vertex would have to be right here, and the coordinates of that are +2, -1. Okay, now we know a parabola is opening down because it opens away from the directrix. So the equation for a parabola that opens down looks like this. Okay, so let's fill in what we need to. So y equals -1 over 4 times p. Well, p is the distance from the vertex to the focus, so that's 2 units. Or it's the distance from the vertex to the directrix, which is 2 units. So we're going to replace this p with a 2. So 4 times 2 would be 8. So we have y equals -1/8, and then x minus, well, h is equal to 2, so x minus 2 squared, and then k is equal to -1. So rather than writing plus -1, I'm just going to write -1. So that matches up with choice 4. All right, so number 16, I'm just going to jump down to the problem. If a student from the high school is selected at random, what is the probability that the student is a sophomore given, I'm going to highlight this, given that the student is enrolled in Algebra 2? Okay, so what we need to do is we need to look at this given category. So if we're given that they're enrolled in Algebra 2, it means we're only looking at these students right here who are in Algebra 2. So altogether, there is 210 plus 85 of them, so altogether there's 295. So that's the total of the given conditions, so that's going to be the denominator of our fraction. Now, probability, we want to know how many of those 295 students are sophomores. So out of these 295 students, 85 of them were in the sophomore circle. So that would be choice 2. Okay, so number 17. You could just plug this in your calculator all at once using alpha y equals and, go to math and plug in the radicals. And then you could plug in the answer choices one by one and see what matches up. But I'm going to do this by hand. All right, so if you want to combine, we have 3 terms that are under radicals. First thing we want to do is we want to get them out of radical form. So if you think about power over root, this is the cubed root of x to the 2nd power. So we could write this as x to the power over root, x to the 2/3 power. All right, so let me write this down here. So this is going to be equal to x to the 2/3 power. So I'm going to use that rule for all of these radicals here. So we're going to multiply that by, again, power over root. Now here we don't see the root. It's actually a square root, so there's a little 2 in there. So this is going to be x to the 5/2 power. And then again, using power over root. The power here is a 1, and the root is a 6. So this is x to the 1/6 power. Okay, so I think next thing I'm going to do is I'm going to leave the denominator alone, x to the 1/6, And if we're multiplying two terms with the same base, we're just going to take these exponents and we're going to add them together. So if you add 2/3 plus 5/2, you end up getting 19/6. So this is going to be x to the 19/6. Okay, now to finish it up, if you're dividing two terms with the same base, you just subtract these exponents. So 19/6 minus 1/6 would be 18/6, which simplifies to 3. So this would be x to the 3rd power. So choice 3. All right, so number 18 wants to know which value is not contained in the solution of the system shown below. Okay, so we want to know which is not a value of A, B, or C. Now, I mean, this is multiple choice, so let's be honest. We're going to set up a matrix in our calculator and let it give us the answers. So over here are the steps as to how we do that. First thing you do is in your calculator, you go to second x inverse, which says matrix on top. You're going to go over to edit, and you're going to set up a 3x4 matrix. Okay, so when you set it up, for example, in the first row, see if there's a 1 in front of the A, a 5 in front of the B, a -1 in front of the C, and a -20 on the right-hand side of the equation. You just plug in 1, 5, -1, -20. So that's what I did, 1, 5, -1. And over here you can't see it because it doesn't fit on the screen, but it does say -20. And then you just follow that through. Okay, now if we look at step 2, it says go to a home screen, and then you're going to go back to second matrix, and you're going to this time go over to math and scroll down until you see RREF. Make sure you don't pick the one that says REF. It should be reduce row echelon form, okay, RREF, and hit enter. And then we go back to matrix for a 3rd time and hit enter again, and let's see what we see. Okay, and this is what we have. So what this means is that A, 1A, is equal to -2, B, 1B, is equal to -3, and C, 1C, is equal to 3. So these are the values of A, B, and C. So you just want to look through the answer choices and see which one is not there. So it looks like choice 2 is not one of the values. All right, number 19. The lifespan of a 60-watt light bulb produced by a company is normally distributed with a mean of 1,450 hours and a standard deviation of 8.5 hours. So the mean is 1450 and the standard deviation is 8.5. All right, so if a 60-watt light bulb produced by this company is selected at random, what is the probability that its lifespan will be between these two values, this many hours? All right, so what they're looking for us to do here is go to normal CDF in our calculator, and we have to plug in a lower bound, which would be this number right here, and an upper bound, which would be this number. So for the lower bound, we'll plug in 1440. For the upper bound, 1465. And then we put the mean, which we know is 1450. And then that will be followed by the standard deviation, which we know is 8.5. And I mean, this is a pretty easy problem because the calculator does all the work for you. And hit enter, and they give you approximately 0.8415. Okay, so choice 3 is the answer. Oh, just one thing. If you forget how to find normal CDF in your calculator, you go to second vars. Okay, vars is right next to clear. Okay, so number 20, a really easy way to do this, it's multiple choices right in the calculator. So in the calculator, plug in the left-hand side of the equation, hit enter, plug in the right-hand side of the equation, hit enter, and see if they equal each other. All right, so like for example, let me show you how to plug number 2 in the calculator. So you want to make sure that A and B are stored as, anything really, other than I wouldn't use 0, 1, or -1, because sometimes things will appear to check out even though they don't. So I'm going to store A is 2 and B is 3. So how you do that is in the calculator you would plug in 2, it says stow, it's right above the on button, A, and hit enter, and then 3, store B, and hit enter. So anytime you hit A in your calculator, it'll represent the number 2, and anytime you hit B in your calculator, it'll represent the number 3. Okay, so now if you notice, what I did was I plugged in the left-hand side of the equation and hit enter. And I plugged in the right-hand side of the equation and hit enter. And since they're equal, it means this is a true statement, so that's not going to be our answer. So you can go through and do this for each of them and see which is the answer. Now, I'm also going to do this by hand just so you can, see how each of them should actually be done. Okay, so if we look at choice 1, this right here is just dots, right? This is a difference of 2 squares. So to factor this, you would set up 2 sets of parentheses, which is what was done here. You would take the square root of 4k squared, which would be 2k, and you put that in the first spot in each parenthesis. And then you take the square root of 49, which is 7, and put that in the second spot in each parenthesis, and make 1 plus and 1 minus. So that checks out. Another way you could have done that is you could have just double distributed, right? 2k times 2k is 4k squared. 2k times negative 7 is negative 14k. Positive 7 times 2k is positive 14k. And 7 times negative 7 is negative 49. And so your 2 middle terms cancel out, leaving you with 4k squared minus 49, which is what the left-hand side of the equation says. So choice 1 is not our answer. All right, number 21, the easiest way to do this question is honestly just to use your calculator. I would just plug this into my calculator and hit enter, and plug in these answer choices one by one and hit enter, and see what matches up. I can also show the work, algebraically, just so you see how to do it. But honestly, I wouldn't even recommend doing that. It's kind of, very time-consuming. Okay, so what I did here was I just double distributed this out and combined my like terms, and it left me with x squared plus 6x minus 7. Now, choice 1 says x plus 3 squared, so I wrote that twice, and I brought down the minus 16. And when I double distributed and combined my like terms, I went up with the same exact thing. You could stop the video now if you want, but if you would like to, I can show you why the other answers don't work. Okay, so choice 2, what I did was, there's another way to do this. I think this is actually the easier way. If you take x plus 3 and write it out twice because it's squared, and double distribute that, and then distribute the negative 10 and the negative 2, and just combine all your like terms, it leaves you with x squared minus 6x plus 23, which is not equal to the original expression. So choice 2 is not the answer. Okay, then if we go to choice 3, all I did was I took this fraction and I factored the x squared minus 6x minus 7. Okay, so I took this x minus 1 and brought it down. And when I factored this, you get x minus 7 times x plus 1. And then I took my x plus 1 and brought it down. And the x plus 1's cancel, leaving you with x minus 1 times x minus 7, which doesn't match up with the original expression because this was x plus 7. Here we have x minus 7. So choice 3 is not the answer. Okay, and then choice 4, I really did the same thing. I took this x plus 7 and brought it down. I factored this to x plus 3 times x plus 1, and then I brought down the x plus 3. And I just canceled off my x plus 3's, leaving me with x plus 7 times x plus 1, which, again, doesn't match up with the original expression because this was an x minus 1, not an x plus 1. So choice 4 is not the answer either. Okay, so just like a lot of questions, I think the easiest way to do number 22 is in the calculator, okay? Plug this into your calculator and hit enter, and plug in the answer choices one by one and hit enter, and see what matches up. I'll do it by hand, just for whoever wants to see it by hand. All right, so I think what I'm going to do to start off is, since 16x squared is a perfect square, I'm just going to take the square root of that. So the square root of 16 is 4, and the square root of x squared is x. So I'm going to rewrite this first term as 4x. Okay, then we have times. I'm just going to bring down the x to the 2/3 for now. Okay, so now if you look at this last radical here, first of all it says plus, so let's put this plus sign before I forget. And we're looking at the cube root of 8x to the 5th. Now 8 is a perfect cube, right? 2 times 2 times 2 gives you 8. So the cube root of 8 is just 2. So let me just bring down a 2. Now the cube root of x to the 5th, well, we can simplify that, but I'm just kind of looking at the answer choices. See how this one says the cube root of x to the 5th, and this one says the cube root of x to the 5th? I'm kind of like looking ahead, and sometimes with multiple choice that's good to do, and I'm going to leave that as the cube root of x to the fifth. Okay, so what we did was, let me just go over that again. We took the cube root of 8. Okay, we took the 8 out of the radical, and we made that a 2. And then I left this as the cube root of x to the fifth. Normally I would try to simplify that, but I mean the answer choices are kind of guiding me in that direction. All right, so let's see what happens. So now here we're multiplying two terms that have the same base. So this really says 4x to the first power. You can put that on there if you want. And this really says 1x to the 2/3 power. So what we do is we multiply the numbers in front. 4 times 1 is 4. And we keep the base of x. And then we're going to add these exponents. So 1 plus 2/3. So it would be like 3/3, right? If you found a common denominator, 1 equals 3/3. So 3/3 plus 2/3 would be 5/3. So we're just adding those exponents. And then I'll bring down the plus 2 times the cube root of x to the fifth. Now, I see radicals in all of the answer choices, so I think what I might do is I might take this and put it back in radical form using power over root. Now, this exponent isn't on the 4, so I'm going to leave the 4 on the outside of the radical, and then I'll rewrite this as the cube root of x to the fifth power. And let me bring this down. This is a unique question. So now we have like terms, because this says the cube root of x to the fifth, and this says the cube root of x to the fifth. So we can just add the coefficients in front of them. So 4 plus 2 is 6. So that leaves us with 6 times the cube root of x to the fifth power. So where is that? Choice 2. Number 23, Sally's high school is planning their spring musical. The revenue R generated can be determined by this function right here, R of t, where t represents the price of a ticket. The production cost C of the musical is represented by the function C of t. What is the highest ticket price to the nearest dollar they can charge in order to not lose money? All right, well, I mean, I guess technically you could do this algebraically, but I'm going to do this graphically. I'm just going to go to y1 in my calculator and plug in this, and y2 in my calculator and plug in this. And, you know, I'm seeing very big numbers here. So you can go to your table of values and adjust the window, but sometimes it's a good idea to just try out zoom fit. Okay, zoom and scroll all the way down to get to 0 and see what it shows. So I'm going to do that. All right, so this is what I see. I mean, to be honest with you, zoom fit sometimes isn't the best. And like here, it's really not the best. Because if we're talking about if this axis represents the price of a ticket, we don't need any of this negative portion of the graph over here. Really, the only part of the graph that we're concerned with is this right here. Okay? Now, we could see that there's two prices that they can charge where they would kind of break even, okay, where they wouldn't lose any money. So we want to know what's the higher ticket price. So this is the higher ticket price. So really all you're going to do is just second trace, intersect, and see where this occurs. Okay, so here we go. I could see I did the point of intersection. I found that this occurs at $8.16, but they want us to round to the nearest dollar, so that would just round to $8. Choice 3. All right, number 24, the profit function, P of x, for a company is the cost function, C of x, subtracted from the revenue function, R of x. So let me just see what that says. So P of x, we know is means equals C of x subtracted from R of x. So if you're subtracting C of x from R of x, we're going to take R of x and subtract C of x from it. Okay, so let's use that equation and see what we need to do. They're asking us to find the cost function, so we're looking for the C of x within this formula. Okay, so what I did here was I just took what they said P of x was equal to and plugged it in, and I took what they said R of x was equal to and plugged it in, and now I'm going to solve for C of x. All right, so you could use it a couple different ways, but I think what I'm going to do is I'm going to add the point 3x squared, and I'm going to subtract the 150x. Okay, so on the right-hand side, this is going to cancel, leaving me with negative c of x. And then on the left side, we're just going to combine like terms. So I get negative 0.2x squared, and then plus 100x. And I'll bring down that minus 300. Okay, now this negative sign here just tells us we could divide everything by negative 1, right? So that's going to leave us with positive 0.2x squared minus 100x plus 300 being equal to c of x. So that would be choice 1. All right, so number 25, all they want you to do is graph this function on this given domain. Okay, so first thing I want to point out is you do not want to graph outside of this given interval. I mean, you may even want to just put those numbers on the x-axis. I don't know if I could fit this with this little pen. That way you know those are the only values on the x-axis that we're using. Let me just move this one over. That one came out pretty bad. Okay, so I guess what I would do is I would just go in my calculator to y equals and create a table of values. Okay, and then all we have to do is just plot these points. Okay, so all I did was just plotted the points, negative 1, negative 10, and so on. Okay, 0, 6. Now, I'm going to point this out again. Do not graph outside this interval. Okay, these are endpoints of our graphs. Don't put arrows. They don't continue on. We want to start at negative 1, graph all the points between that and positive 4, end at 4, and just label your graph. If you put arrows, unfortunately, that would be, you would only get 1 out of 2 points for this 2-point question. Okay, the volume of air in a person's lungs as the person breathes in and out can be modeled by a sine graph. Okay, so this is what I picture, right? The person's breathing in, and there's more volume of air in the lungs, and then they're breathing out, and there's less, and then it goes back to normal again. Then they breathe in and out, so it continues on and on. Okay, the scientist is studying the difference in this volume for people at rest compared to people told to take a deep breath. When examining the graphs, should the scientist focus on the amplitude, period, or midline? Explain your choice. Okay, if we're looking for differences in volume, well, volume would be your y-axis, how high and how low it's going to go. So let's start. I'm going to start with this, the midline. The midline would just be the middle height of the graph. That's not going to change. That's not going to change whether we're looking at people at rest or people taking a deep breath. The middle is the middle. Okay, the period is how long it takes to complete the cycle. All right, that's not going to help us with differences in volumes. The amplitude, how high it's going from the midline or how low it's going from the midline, that's going to help us with the differences in the volumes, how far up and down we're going from the midline. All right, 27, the scores of a recent test taken by 1,200 students, I'm just going to underline that, had an approximately normal distribution with a mean of 225 and a standard deviation of 18. Okay, determine the number of students who scored between 200 and 245. All right, so it looks like we're going to do a normal CDF here. And if we want to find, first of all, we want to find the percentage of people that scored between 200 and 245. So 200 would be our lower bound. 245 would be our upper bound. And then we would list out the mean, which was 225. And then we would give the standard deviation, which is 18. Now, to get to the normal CDF in your calculator, what you do is you go to second vars. Vars is the button just to the left of clear. And then you're going to go down to choice 2, normal CDF. Make sure you pick the one with CDF, right, not PDF. And lower, upper, mean, standard deviation. Okay, so when we do that, I'm just going to hit enter. We get approximately 0.7843. Okay, now, if they wanted us to determine the probability, that would be the answer. But they want us to determine the number of students. So what we want to do is, out of the 1,200 students, about 78.43% scored between these. So we want to figure out what is this percent of 1200. So I would leave that exact number in your calculator. I'm going to just rewrite the approximation of that number here. But you want to take that percentage and multiply it in your calculator by 1200. And when you do, it gives you about 941.2. Now we're talking about the number of students. You can't have a decimal of a person, so you're just going to round to the nearest whole number, so that would be 941 students. Number 28 wants us to explain, so that means we're going to have to use words for this, how 3 to the 1/5 squared can be written as the equivalent radical expression, the 5th root of 9. Okay, so the first thing we're going to do is, if you have a power raised to another power, you're just going to multiply these exponents. So 1/5 times 2 over 1 would just be 2/5. So I'm going to rewrite this as 3 to the 2/5 power. And then we just have to explain. I'm just going to go like this. I'm going to put arrows showing what I did. I'm just going to explain in words how I went from one step to the next. Okay, so when you raise a power to another power, you just multiply. So you're going to multiply the exponents. 1/5 times 2 is 2/5. Okay, now what we're going to do is we're going to use our rule, power over root. We can rewrite this as the 5th root of 3 to the 2nd power. Now, one thing I want to point out, the 2nd power, the exponent of 2, you could either put on the outside of the radical here, or you could put it on top of the 3, under the radical. If you look at how they want you to rewrite this, they want a 9 under the radical. So instead of putting the square on the outside of the radical, I'm going to put it right there on the 3. Okay, sometimes you want to look ahead and see what they want you to do. All right, so let's write out the rule. Okay, so what we did to get from this step to this step, we just used power over root, okay, to rewrite this. When raising a term to a fractional exponent, the numerator represents the root, and the denominator represents the power. Okay, now from here it's really easy. All we have to do is 3 squared is 9, so that will lead us to the 5th root of 9, which is what they wanted us to get. So we can rewrite that as the 5th root of 9. Okay, now let's write the rule to get from here to here. Okay, so there wasn't really much to write there. All we did was square the 3. So 3 squared equals 9. Number 29, they want us to solve the system algebraically. All right, well, so we're going to use substitution. Since y is equal to x minus 28, we're going to take the x minus 28 and substitute it into the first equation for y. So instead of having x squared plus y squared equals 400, we're going to have x squared plus what y is equal to, x minus 28 squared equals 400. Okay, so let's solve this. Now we have an equation with just x's in it, so we can solve it. So we'll bring down the x squared, and since we have the x minus 28 being squared, what that means is there's 2 of them being multiplied together. So we'll write it out twice, and we can double distribute. Alright, so let me first bring down this x squared, and when we double distribute, x times x is x squared, x times negative 28 is negative 28x. Again, negative. Now we're distributing this one. Negative 28 times x is negative 28x. And negative 28 times negative 28 is positive 784. And now we'll bring down the equals 400. All right, so whenever you have x squareds in your equation, you want to get one side of the equation set equal to 0. So the easiest way is to subtract the 400. Oh, I'm missing the x here on that 28, I just realized. And when we do that, we'll have 0 on the right-hand side of the equation. So now on the left-hand side of the equation, let's combine all of our like terms. So x squared plus x squared is 2x squared. And then negative 28x and negative 28x would be negative 56x. And then I'm just combining the numbers here. 784 minus 400 is positive 384. All right, and this is awesome because since, that's supposed to be a 4. Since these are all even numbers, we can just divide by 2. And that's going to make our life so much easier when it comes to factoring when we have a 1 in front of the x squared. right, so now I'm going to just divide each of these numbers by 2. So negative 56 divided by 2 is negative 28. So we have negative 28x. And then positive 384 divided by 2 is 192. All right, so let's factor. So what we need to do is we need to come up with two numbers that add to negative 28 and multiply to 192. Now, if you have trouble doing that, remember, you can always use your calculator and go to y equals and plug in this number, 192, divided by x, and scroll up and down through the table of values until you find two numbers that add to negative 28. All right, so again, you can go to y equals and plug in this number divided by x, and you could see when you go to your table of values, I mean, I knew if they were going to add to a negative, I kind of scrolled up till I got to the negatives, and you can see right here that, I mean, whether you're looking at negative 16 and negative 12 here, or negative 16 and negative 12 here, those add to negative 28. Okay, so let's go back to our problem. So what we're going to do is, when we factor this, this is going to be x minus 12 times x minus 16. And then we'll just make a t-chart and solve. So we get x equals 12 and x equals 16. Now, these are just the x values of the points of intersection, right? When you have a system of equations with x and y's, what you want to do is you want to write your final answers as coordinates. So you want to x comma y. So now we know that the x values for our answers are going to be 12 and 16. So let's find the y values that go along with them. So I'm going to use this equation right here. This is going to be pretty straightforward. So we can plug in 12 for x and see what y is equal to. And then after that, we'll plug in 16 for x and see what y is equal to. All right, so we have y equals, we'll start off with the 12 minus 28. So that's going to be equal to negative 16. So these two values right here group together to form a coordinate. So 12, negative 16. Okay, now let's do the same thing over here. Y equals, this time we're going to replace the x with positive 16. And 16 minus 28 is negative 12. So that right there is going to lead to our other point of intersection. When x is 16, y is negative 12. And these are really easy to check because you can always just take this x value and this y value and substitute it into both equations to make sure they check, and then do the same exact thing with your other coordinate. Okay, number 30, they want us to just simplify this expression. Now, I have a feeling what a lot of people are going to do is bring down the xi, and because this is squared, I have a feeling a lot of people are going to want to jump right in and write it out twice and double distribute, which you totally can do, because that's normally what we do when something is squared. But if you kind of look a little bit more closely at it, isn't I and negative 7i, aren't these like terms? If we just combine our like terms, I think it's going to make our life a lot easier. So I minus 7i is negative 6i. And then I'll bring down the squared. Okay, so now I'm going to bring this xi down, and I'm just going to square this. Negative 6i squared, you would square the negative 6, so that would be positive 36, right? Negative 6 times negative 6 is positive 36, and then you would square the I, so that gives you I squared. Okay, now you could do one of two things. You could multiply these out, but I'm actually going to get rid of the I squared. So let me bring down the xi, right, because we know we don't want to leave exponents on i's. So we know I squared is equal to negative 1, so I'm going to replace that with a negative 1. So now to finish, we just have negative 36 times xi, and that is going to be your answer, negative 36 xi. And if you wanted to check, I mean, you can always just plug this original expression into your calculator and hit enter, and you can plug this expression into your calculator and hit enter, and just make sure they match up. Okay, so 31, they give us, it looks like a pretty, lengthy formula for a mortgage payment. Actually, M stands for monthly payment. So it says the Wells family is going to purchase a home in a suburb of Rochester with a 30-year mortgage that has an annual interest rate of 3.6%. The house the family wants to purchase is $152,500, and they will make a $15,250 down payment and borrow the remainder. use the formula below to determine their monthly payment to the nearest dollar. All right, well, what's nice about this question is they're having us determine M, the monthly payment. So all you really have to do is plug numbers into everything over here, and then your calculator's going to do all the work for you. All right, so let's get started. So we're going to have M equals, all right, P stands for the amount borrowed. Now, we know how it works is, we know that if you know the price of a home and they have a down payment, this is money that they're going to pay towards the price of the home so they don't have to borrow as much. So what's going to happen is if we take the price and subtract off their down payment, that's going to leave us with how much they want to borrow. Okay, so you can see that right here. This is the price of the home. This is how much money they've saved up that they're going to use as a down payment so they don't have to borrow as much. And when you subtract these, whatever you're left with is what you're going to borrow. So this is what I'm going to put in for the amount borrowed, for the P. All right, so let me make a big fraction here. So now we know that R, the rate, is, 3.6%. So if we take the decimal and move it back twice, that becomes 0.036. So that's what we're going to replace all the R's in the formula with. Okay, so we're putting that over 12 because that's given in the formula. So then we have 1 plus, again, the rate divided by 12. Now, N stands for the total number of monthly payments. So we know there's 12 months in a year, and they're taking out a 30-year mortgage, right? So N is going to be equal to number of months in a year times the number of years we're taking this loan out for, so 360. Okay, so then we're going to have 1 plus 0.036 divided by 12 over 360, and then minus 1. Okay, so just plug everything in. Now from here, all you have to do is just plug everything in your calculator. I would use alpha y equals and plug in this expression as a whole. A lot of times when people try to do it in parts, that's where mistakes are made. Okay, so this is what it looks like in the calculator. I couldn't fit you can't see it all on the screen, but they want you to round to the nearest dollar. So to the nearest dollar, that would be $624. Number 32 wants us to graph this function over the domain from 0 to 2 pi. Okay, so first thing I like to do is I like to just make a list of everything we know about our function. All right, so let's see. The amplitude is the number in front of the word sine, 3. The frequency is what's in front of the x, which we have a 2. The period we know is equal to 2 pi over the frequency, so that would be 2 pi over 2, which 2's cancel off and simplifies to pi. The vertical shift is this 2 that's being added to the end of the function over here. The minimum we know is equal to the vertical shift minus the amplitude. So 2 minus 3, which is -1. And the maximum would be your vertical shift plus your amplitude. So 2 plus 3, which is 5. Okay, so the min and the max help us set up our y-axis. The period and frequency, I guess, helps us set up our x-axis. So let's start off with the y-axis. Now, it's up to you. I mean, we have to number up to 5 and down to -1. You could skip boxes if you want, or you don't have to. I'm going to skip boxes. All right, so there we go. I only numbered down to -1 and up to 5. Now, along the x-axis, we know that they want us to graph from 0 to 2 pi, and we know that a period is pi. So what that means is once we reach pi units, we will fit one complete sine curve. Now, since I jump boxes here, my graph is going to be pretty high, so I think what I'm going to do is, normally we jump 2 boxes and put pi over 2, 2 boxes and put pi, 2 more and put 3 pi over 2, and 2 more and put 2 pi. I'm going to space that out even more, just so my graph isn't so tall and skinny. So rather than skipping 2 boxes, I'm going to jump 4 boxes, and this is where I'm going to put my pi over 2. Okay, so I'm just jumping twice as much as we normally do. Okay, then I'm going to jump 4 more boxes, 1, 2, 3, 4, and this is where I'm going to put pi, and so on. So 4 more boxes will be 3 pi over 2. And 4 more boxes will be 2 pi. Okay, now on my graph I like to put a dotted line where our vertical shift is. So since we have a vertical shift of 2, I'm just going to put a dotted line at 2. Okay, so our midline would be y equals 2. All right, so now we need to fit, since the period is pi, it means that we need to fit a complete sine curve between 0 and pi. So what that means is this other point here that'll be on our midline will be halfway between 0 and pi, so at pi over 2. So let me start by plotting that. So here's one cycle. Here's the first point of our cycle. Here's the last point of our cycle. And here's the point that's right in between them. Now we know halfway between 0 and pi over 2, we're going to be up at a maximum. So halfway between 0 and pi over 2, okay, would give me this box. At this box, I'm going to be all the way up here at a maximum. So let's put a point right there. Now we also know that halfway between pi over 2 and pi, we're going to be down at a minimum. So halfway between pi over 2 and pi, we're going to be down here at a minimum of -1. Okay, so this is what the first cycle of our sine curve looks like. Now they want us to graph this between 0 and 2 pi, so we're going to fit a complete another cycle. So I'm just going to do the same thing. I'm going to make, so ready? We know that here is the starting point of our sine curve. We know it's going to take another pi units to finish it, so at 2 pi we'll finish it, and halfway between them will be on the midline. Now halfway between these 2 points, we're going to be up at a maximum. And we know midway between these 2 points, we're going to be down at a minimum. And there we go. Okay, whenever they give you an equation, you are going to want to label that on the graph. So there we go. Okay, number 33 asks us to do a few things, but the first thing they want us to do is to evaluate j of -1. So all they want us to do is just replace all of these x's with -1s in parentheses, and then just evaluate, figure out what it's equal to. Okay, so I just replaced all of these x's with -1s, and to be honest, I think your best bet is to just use your calculator to determine what this is all equal to. So you could type it in your calculator exactly like you see here, or I find it easier just to take -1, hit store and then x and hit enter. So whenever we hit an x, it's representing -1, and then you don't have to worry about parentheses. You're just plugging in this exactly like you see it, and you could see here that it's equal to 0. So j of -1 is equal to 0. Okay, then they want to know, explain what your answer tells you about x plus 1 as a factor. Well, if x equals -1 is a 0, then what that means is that x plus 1 is a factor. Okay, so just put that in words. Since j of -1 equals 0, x plus 1 is a factor of j of x. All right, and the last part of this question says to algebraically find the remaining zeros. So we need to algebraically, we know that x equals -1 is a 0 of this function, but we need to algebraically find the remaining zeros. Now, in order to do so, usually you would set an equation equal to 0, factor, and make a t-chart, but this is something that, with the 5 terms here, that we're not really able to factor. But if we know that x plus 1 is a factor of this expression, let's divide this by one of its factors, and what we're left with should give us another factor. Okay, so let me say that again. Since x plus 1 is a factor, it should divide evenly into this expression. And what we'll be left with will be another factor, which, we could tell we're going to have to factor further because of these big exponents here. All right, but let's start off with long division. So you want to say, what can I multiply x by to give me 2x to the 4th? Well, 2x cubed. All right, and then we're going to take the 2x cubed and distribute it to both terms. So 2x cubed times x would be 2x to the 4th. And then 2x cubed times 1 is 2x cubed. Okay, so then we're going to change the sign and circle, change the sign and circle. So these cancel off. Now if I combine a negative x cubed and a negative 2x cubed, that's going to give me negative 3x cubed. And then we can bring down the next term and repeat the process. So now you say, what do I multiply x by to give me negative 3x cubed? So negative 3x squared. And now we'll distribute the negative 3x squared to the x plus 1. So negative 3x squared times x is negative 3x cubed. And then negative 3x squared times 1 is negative 3x squared. We're going to change the sign and circle, change the sign and circle. So again, the first two terms will always cancel off, as long as you're on the right track. And then when you combine these, you get negative 32x squared. And the reason why we bring down the next term is because if we have two terms out here, we need two terms down here. All right, so what do I multiply x by to give me negative 32x squared? So negative 32x. And then we're going to distribute this to the x and this to the 1. So negative 32x times x is negative 32x squared. And then negative 32x times 1 is negative 32x. Okay, so change the sign and circle. Change the sign and circle. These cancel. And when I combine my like terms, I get 48x. And then when I bring down the 48, we could say, what do I multiply x by to give me 48x? Well, just 48. And we're hoping for no remainder, because if there's a remainder, it means we made a mistake somewhere. This should divide evenly with no remainder. So 48 times x is 48x, and 48 times 1 is 48. And again, how I knew there would be no remainder is because x plus 1 is a factor. So when we change our signs and circle, everything cancels, and luckily we have no remainder. Now we're not done here because they want us to algebraically find the remaining zeros. So we know the zero that goes along with this factor is x equals negative 1. Okay, we already talked about that. Now we need to find the zeros that go along with this expression right here. So what we're going to do is, if we want to find the zeros, we're just going to take that expression and we're going to set it, I can't fit the 0, I'm going to put it over here. We're going to set it equal to 0 and then just solve. So here we would factor by grouping. So it leaves us with 0 equals. So to the first two terms, I could pull out an x squared, which leaves me with 2x minus 3. And out of the next two terms, I could either pull out a positive 16 or a negative 16. Now, if I want to be left with positive 2x and a negative 3, I'm going to pull out a negative 16, because negative 32x divided by negative 16 is positive 2x. And then 48 divided by negative 16 is negative 3. And we wanted, sorry, this is kind of squished in here, we wanted these two parentheses to match up, which they do. All right, so that leaves us with 0 equals. Now we're going to take the x squared and the minus 16 that are on the outside of the parentheses, and we'll group them together. And then we'll bring down that common binomial that we see, and that creates our factor of 2x minus 3. Now it's up to you. You can make a t-chart at this point, or if you want to factor further, we know that x squared minus 16 factors to x plus 4 times x minus 4. And once we make a t-chart and solve, we will wind up with our remaining factors. All right, so here we wind up with x equals negative 4. Here we're going to wind up with x equals positive 4. And here you're going to wind up with x equals positive 3 over 2. If you can't look at it and do that, I mean, it's pretty easy. Just take 2x minus 3 and set that equal to 0 and just solve. So if you add 3 to both sides, that leaves you with 2x equals 3. And then when you divide by 2, you get x equals 3/2. So these are the 3 remaining zeros. Okay, we already determined that x equals negative 1 was a 0. So these are the remaining 3. These are the only 3 you want to circle. Okay, and it makes sense that altogether there's 1, 2, 3, 4, right? Because this was a 4th degree function. So that's the maximum number of zeros you can have. Number 34 asks us to solve this equation algebraically, and justify the solution set, which, I mean, all that really means is just to check, okay? So justify just means to check. All right, now when you solve a radical equation, the first thing you want to do is you want to get this radical all by itself. So we can do that by just subtracting x from both sides of the equation. Okay, so that's going to leave me with the square root of 2x minus 7 equals 5 minus x. Now to get rid of a square root, you just square it. So if I'm going to square the left-hand side of the equation, I'm also going to square the right-hand side of the equation. So like we said, a square and a square root cancel each other out. So on the left-hand side, I'm left with 2x minus 7. And then on the right-hand side of the equation, if something's being squared, it means we have two of them. So I'm going to just write it out twice and then double distribute. Okay, so let me bring down the 2x minus 7. And when I double distribute, I'll get 25 minus 5x minus 5x plus x squared. Okay, so let me move everything. I like to move everything to the same side of the equation that the positive x squared term is on. So I'm going to subtract this 2x, and at the same time, I'm going to add 7. So I'm going to subtract 2x. I'm going to line that up under my x terms, and I'm going to add 7. I'll put that underneath the numerical term. All right, so on the left side, everything cancels, and I'm going to rearrange. So I'm going to take my x squared term and write that first. And then I'll take these terms with the x's on it and combine them to give me negative 12x. And then 25 plus 7 is 32. This problem is actually not so bad because it's a nice, easy factoring. All we have to do to factor this is set up two sets of parentheses. And since this first term is an x squared, we're going to put an x and an x. And we want to come up with two numbers that add to negative 12 and at the same time multiply to positive 32. So if they multiply to a positive, they have to have the same sign. And if they add to a negative, they're both going to be negative. So two numbers that work in this situation are negative 8 and negative 4. All right, so then we'll make a t-chart and solve, and we end up getting x equals 8 and x equals 4. Now, when they say to justify your solution set, they're actually helping you out there. They're giving you a clue that you have to check your answers, because sometimes, I mean, you could solve everything right, and these answers may not check back in the original equation, and we call those extraneous roots. Okay, so let me check off to the side here. So check number 1. Okay, let me first check this x equals 8. So I'm going to take 8 and substitute it back into the original equation wherever I see an x. So I'll have the square root of 2 times 8 minus 7. And then we'll have plus, in place of the next x, I'm going to put an 8, and we'll see if that equals 5. Okay, so 2 times 8 is 16, and 16 minus 7 is 9. So here we'll have the square root of 9 plus 8. And I'm going to bring down the equals 5. I should really put a question mark on top of this because we don't know if that's true, if that really equals or not. So since the square root of 9 is 3, 3 plus 8 is 11, which definitely does not equal 5. So what happens is x equals 8 doesn't work for us. That's called an extraneous root. It does not check back into the original equation. Okay, so now let me check the 4. So I'm going to take the 4 and substitute it back into the original equation wherever I see an x. So I'll have the square root of 2 times 4 minus 7, and then I'll replace the plus x with a plus 4, and let's see, does that equal 5? Okay, so well, 2 times 4 is 8, and 8 minus 7 is 1, so we have the square root of 1, which I'm just going to jump down. The square root of 1 is 1. So we have 1 plus 4 equals 5, and yes, 1 plus 4 is 5, so this one checks out, so x equals 4 is our solution. Okay, you could hit pause and read number 35, but the gist of it, the gist of the question is that Ava took 20 students, she randomly put 10 of them into group 1 and 10 of them into group 2, and group 1 was given an energy drink, and group 2 was given a cola drink, and she wanted them to read a paragraph and see, who read them faster. So down here it says, Ava thinks energy drinks make students read faster. Using information from the experimental design or the results, explain why Ava's hypothesis may be incorrect. Okay, well, if you look here, the students who drank the energy drink in group 1, they read the paragraph faster, on average, than the students who drank the cola. But we can't say that it was due to the energy drink that made them read faster. I mean, it could be, who knows, maybe all the students who just read faster were placed in group 1, and that could account for the difference in the mean reading times. It could have just been based on random assignment, who was assigned to what group. We can't say that it was necessarily due to the energy drink. This sample size, 10 students here and 10 students here, is way too small to make that conclusion. Okay, so let me write this out in words. Okay, so I put her hypothesis may be incorrect because other outside factors may have contributed to the difference in mean reading times. The sample size is way too small to conclude that it is due to the energy drink. Okay, so other outside factors definitely could have contributed to the difference. Okay, so using the given results, Ava randomly mixes the 20 reading times, splits them into two groups of 10, and simulates the difference of the means 232 times. Ava has decided that the mean difference in reading times is not an unusual occurrence. Support her decision using the results of the simulation. Explain your reasoning. Okay, so if we want to figure out if something is an unusual occurrence or not, we have to figure out where it lies in the distribution and if it occurs, frequently or infrequently. All right, so let's see. Let's first subtract. It says group 1 minus group 2. So group 1 read the paragraph on average in 17.7 seconds. And group 2 on average read the paragraph in 19.1 seconds. So if we subtract these two values, we wind up getting negative 1.4. Okay, so the difference in reading times was negative 1.4. So that means that group 1 read the paragraph 1.4 seconds faster than group 2. All right, so let's see where that difference lies on this chart. So if this is negative 1.6 and this is negative 1, you can see it goes negative 1, negative 1.1, negative 1.2, negative 1.3, negative 1.4 is on this bar right here. So what we're going to do is we're going to look at this bar as well as anything more extreme than it, so anything even more negative than it. So let me just kind of circle those values. So we're going to look at everything right here, and we want to add them up. So if you add them up, right, if these are all at a height of 1, this would be 1, whereas the height of this bar would be 2. So if we add those together, it gives us 3. So let's count it. We get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So this adds up to 25 out of the 232 simulations that she did. So 25 out of 232. Okay, so if you can plug it in your calculator if you want. It is approximately 0.1078. So that is approximately 10.78%, or I'm just going to round it to 11%. Okay, so a difference that extreme, or even more extreme, occurs 11% of the time. Well, that's, as long as it's something that is not totally unusual, as long as it's a percentage that's greater than 5%, you could say that that is a normal occurrence, okay? It is not unusual, okay? So here, let me just write this out in words. Okay, so here I'm saying that the mean difference in reading times is not an unusual occurrence because a mean difference, and I'm going to point this out. Some of you guys are forgetting to write this in your explanation, of negative 1.4 or less. It's important to say or less because we're not just looking at the 3 times that negative 1, a difference of exactly negative 1.4 occurred. We're looking at that or anything even more extreme than that. So it's really important to say or less. Or if you're on this side of the distribution, you would say or more, right? Because you're looking at everything more extreme than it. But anyway, that occurs more than 5% of the time. Okay, you don't have to say this. It occurs approximately 11% of the time because we showed that up here. But everything else you do need in that explanation. Number 36, to determine if the type of music played while taking a quiz has a relationship to results, 16 students were randomly assigned to either a room softly playing classical music or a room softly playing rap music. The results on the quiz were as followed. Okay, so we can see that right here, and then it says, John correctly rounded the difference of the means of his experimental groups as 7. How did John obtain this value, and what does it represent in the given context? Justify your answer. Okay, so what he did was he just added up the 8 people who took the quiz while listening to classical music and divided them by 8, and he wound up getting an average of 82. Then he did the same thing with the rap group. He added up these 8 scores, divided by 8, and he wound up getting an average of 74.625. And when he subtracted them, he got 7.375, which rounds to 7. So I just said right here, John found the average quiz grade of the students listening to the classical music by adding up their scores and dividing by 8. He then did the same thing with the rap group. He then subtracted these 2 mean values, which I'm showing right here, to obtain a mean difference of 7.375, which rounds to 7. Okay, now they want to know, what does this represent in the given context? All right, so right here, the students who were assigned to the room playing classical music scored 7 points higher on their quiz, on average, make sure you say on average, because that's really what it is, than those students who were assigned to the room playing rap music. I guess you just have to tell what the 7 represents based on this situation. Okay, to determine if there's any significance in this value, John re-randomized the 16 scores into 2 groups of 8, calculated the difference of the means, and simulated this process 250 times as shown below. Okay, so that means that there's going to be a total of 250 dots because he did 250 simulations. Now what we want to do is we want to figure out if a difference of 7, which if this is 5, here's 6, here's 7, of 7 or anything even more extreme than 7, so 7 or greater, we want to see if this is a significant difference, if it occurs so infrequently that it was due to the type of music they were playing. All right, so let's figure it out. So here's where 7 is, and we want to look at this value, a difference of 7 or anything even more extreme. So that occurred 4 times, right? Just count the dots. 1, 2, 3, 4 out of the 250 dots, the 250 simulations that we see here. So this is equal to 0.016, which if you just take the decimal and move it twice, is 1.6%. So that is not a common difference, okay? That difference was so extreme. Okay, that difference occurs, we could say, less than 5%. So this is not a normal occurrence. So a difference this extreme, since it occurs so infrequently, it's not likely due to chance of random sampling of the groups. It's more likely due to the type of music they were listening to. Okay, so here's my explanation, and I underlined some important words. I said, yes, the simulation supports the theory that there may be a significant difference in quiz scores because a difference of 7 or more occurs less than 5% of the time. I know when I was reading some of your explanations, instead of saying what the difference was and saying or more extreme, right, 7 or more, or if it was down here, -5 or less, make sure you state the difference as well as or more or less, because you're not just looking at that value, you're not just looking at it, you're looking at that value as well as anything more extreme. So anyway, because this occurs less than 5% of the time, a difference is of 7 or more, we would say that yes, there is a significant difference. Okay, number 37, a major car company analyzes its revenue, R of X, and costs, C of X, in millions of dollars over a 15-year period. The company represents its revenue and costs as a function of time in years X using the given functions. All right, so they give us these here. The company's profits can be represented as the difference between its revenue and costs. So difference would be R of X minus C of X. Write the profit function P of X as a polynomial in standard form. Okay, so they want us to represent the profits P of X So we know that P of x is equal to, let me just write this out, P of x is equal to R of x minus C of x. Now, we know if we want to subtract C of x from R of x, right, you want to subtract each one of these terms from the term above it. So in order to show that you're subtracting, I mean, really what you do is you change all the signs. So this is going to become a negative 880x cubed. This is going to become a positive. This is going to become a negative. And this is going to become a positive. And then all you have to do is really just combine your like terms, right? You can combine these first two terms. Then you can combine these next two terms. And then we can combine these terms with the x's on them. And then we could just combine the numerical terms at the end. Okay, and when we do that, you can see this is what we're left with. Okay, these combine to give us negative 330x cubed. These two terms combine to give us positive 9,000x squared. These two terms combine to give us negative 67,000x. And these two terms combine to give us positive 167,000. Okay, so this is the profit function P of x, and now what they want us to do is they want us to graph it on the set of axes below. And they want us to do it over this domain. So what we're going to do is we're going to go to y equals in our calculator, and we're going to plug in this function, and then we're just going to look at the table of values and graph it for every point between and including 2 all the way up to 16. Okay, so in my calculator, this is what I get in my table of values. You don't have to write this on your paper. I mean, it doesn't hurt to write it, but I just put it here so you could see the numbers I got. And if you notice, we're actually just going to be using this first quadrant, right, where the x and the y are both positive. Now, don't forget to label your x and y axis as well as number them. So once I do that, let me just show you what my graph is going to look like. All right, so here we go. So I just took all these points, and, you know, it's an estimation, but I plotted them. And notice I didn't put arrows, okay? I started at 2 and ended at 16. Okay, now let's get to the question on the bottom of the page. Okay, so it says over the given domain, so from 2 to 16, state when the company was least profitable and the most profitable to the nearest year. Explain how you determine your answer. All right, well, we could see it was least profitable right here, okay, at the 5th year, and it was most profitable right here at the 13th year. Okay, if you want to use your calculator and find the relative minimum and the relative maximum, you can go to second trace, and then you could choose minimum, and you want to put a left bound and a right bound, and you'll see this occurs exactly at 5.2 years, which rounds to 5. And if you, in your calculator, same thing, second trace, and then go to relative maximum, and you put a left bound and a right bound, you'll see this occurs at exactly 12.96 years. Okay, but they want it to the nearest year. So the 5th year and the 13th year. Okay, so I just wrote this out in words. It just says the company was least profitable in the 5th year and most profitable in the 13th year because this is where the function reaches its relative minimum and relative maximum, rounded to the nearest whole number. You also could have used your table of values and given a different explanation. So let me just show you what I put there as well. Okay, you could have also used, I mean, if you look at the table of values, you'll see that in the 5th year, this is the lowest profit, and in the 13th year, this is the highest profit. So I just wrote out the company was least profitable in the 5th year because, now notice I changed this into millions because up above it said it was in millions. So because 15,750,000 is the lowest value in the given domain, it's actually the lowest y value, right? And the company was the most profitable in the 13th year because 91,990,000 is the highest, I should say here, y value in the given domain.